Assalamu alaikum everyone, I hope everyone is well. So this is a continuation video of my previous video which was about solving mathematical facts using algebra. So in this video I'm going to go through different set of problems regarding this topic, which is using algebra to prove mathematical facts. So let's jump straight into with the Blackboard intro. So problem number 4 says you have to prove that twice n plus 3 whole square minus twice n minus 3 whole square is a multiple of 8. So this problem is similar to number 2, where you have to prove that thrice n plus 1 whole square minus thrice n minus 1 whole square is a multiple of 4. So check out that video and find out how you can do number 4. So I'll go to number 5, which is you have to prove algebraically that the difference between the squares of any two consecutive integers, this is very important, consecutive integers, the difference between the squares of any two consecutive integers is equal to the sum of these two integers. So if I go to my notepad and use the pen tool, let's say these two consecutive numbers are n and n minus 1. So the difference between the squares of these two numbers, let's say the square of n is n square and the square of n minus 1 is n minus 1 whole square. So the difference between the squares of these two consecutive numbers, you have to prove that this expression is the same as the sum of these two numbers, which is n plus n minus 1. So if you go to this, if you look at this term, what is this term? If we expand this term with the formula of a minus b whole square, we get n square minus n square minus twice n plus 1. So this is what? N square minus n square. If we take out the brackets, it will be plus twice n minus 1. So we can cut off these two terms, the square terms, we get twice n minus 1, which is n plus, which we can also write as n plus n minus 1. So if you look at this term, this is the same as this term, n plus, or this expression, sorry, n plus n minus 1, right? So this expression is indeed the same as this expression. So the difference of the square of two numbers is the same as the sum of these two numbers. So now let's use a practical example. Let's say n is a positive number, let's say n is 7. So what is n minus 1? 6. So the difference of the square of these two consecutive numbers, 7 square minus 6 square, is what? 49 minus 36, which is what? 13. So 13 can also be expressed as 7 plus 6. So the difference of the squares of these two consecutive numbers is indeed the sum of these two numbers. So you can use any positive numbers of n and n minus 1 to check whether this mathematical fact works or not. Problem number 6 is similar to problem number 4 and problem number 2. So that's the homework for you. So I'll go to problem number 7. It says, if twice n is always even for all positive integer values of n, you have to prove algebraically that the sum of squares of any two consecutive even numbers is always a multiple of 4. So you have to prove that the sum of the squares of any two consecutive even numbers is always a multiple of 4. So if I go to my notepad and use my pen tool, let's say for any positive integer n, twice n is an even number. So what is the immediate next even number? Twice n plus 2. So you have to prove that the sum of the squares of these two numbers. So what is the square of twice n? Twice n square plus the sum of these two numbers, the square of these two numbers, twice n plus 2 whole square. This expression is always a multiple of 4. So what is this expression? If we simplify this expression, it has, what is twice n square? Twice n whole square, which is 4n square, plus, if you use the formula of a plus b whole square, twice n whole square plus 2 multiplied by twice n multiplied by 2 plus 2 square. So if we simplify the expression more, it is 4n square plus 4n square, twice n whole square is 4n square, plus 2 multiplied by 2, 4 multiplied by twice n, which is 8n, plus 2 square is 4. So as you can see, there is 4, 4, 8 and 4. So you can use 4 as a common term. So what is the expression? N square plus n square plus twice n plus 1, or can be simplified more as 4 multiplied by twice n square plus twice n plus 1. We can use it in a formula or to keep it like this. So let's see if we can use a formula here. So if we use twice n, or maybe 4 multiplied by twice n and n plus 1 plus this one. So if you look at this term, there is a 4 here. So for any positive value of n, this expression will always be a multiple of 4. So let's use an example. So let's say n is a positive number. Let's say n is any number. Let's say 7. So twice n is what? 14. So what will be this expression? What will be the result? 4 multiplied by 14, 4 multiplied by 14 multiplied by 7 plus 1, which is 8, plus 1. So what is the result? 14 multiplied by 8 is 10 multiplied by 8 is 80, and 8 4s are 32. So 80 and 32 is 112, and 113. So 4 multiplied by 113. So whatever the number is, it's probably 452, whatever. But you can see that this expression 4 into 113 is a multiple of 4, because you can clearly see the 4 is there. So you can use any positive number of n, and you will see that this expression is a multiple of 4. So number 8 says you have to prove that n plus 1 whole square minus n minus 1 whole square plus 1 is always odd for all positive integer values of n. So if I go to my notebook and use my pen tool and write the expression n plus 1 whole square minus n minus 1 whole square minus, or is it plus 1, okay, plus 1, this expression will always yield an odd number. So if we simplify this expression using the formula of a plus b whole square minus a minus b whole square, which is 4ab, in this case it will be 4 into n into 1 plus this one, which is 1. This can also be simplified as 4n plus 1. So if you look at this expression, especially this term, for all positive integer values of n, let's say n is 1, 2, 3 and so on, what will be 4n? 4, 8, 12 and so on. So what will be 4n plus 1? 5, 9, 13 and so on. So as you can clearly see that 4n plus 1, this expression will always yield an odd number for all positive integer values of n. Problem number 9 says you have to prove algebraically that the sum of the squares of any two consecutive numbers always leaves a remainder of 1 when divided by 4. So if I go to Notepad and use my pen tool, let's say one number is n. So what is the next consecutive number? Let's say the previous consecutive number is n minus 1. So you have to, what is the square of n? N square. And what is the square of n minus 1? N minus 1 whole square. Right. So you have to prove that the sum of the squares of these two consecutive numbers, this expression will always leave a remainder of 1 when it is divided by 4. Always leaves a remainder of 1 when divided by 4. So if I simplify this term with the formula of a minus b whole square, you can write n square plus, if you use the plus, then we can take out the square brackets and use n square minus twice n plus 1. So we can also write this as n square is twice n square. Twice n square minus twice n plus 1. We can take twice n common from the first two terms and write twice n multiplied by n minus 1 plus 1. So this is the simplified term. So for all positive values of n, let's say n is positive integer values. So it starts with 1, 2, 3 and so on. So what is the value of twice n? For n having values of 1, 2, 3 dot dot dot. Twice n would be 2, 4, 6 dot dot dot. And what would be the value of the term n minus 1 for n being 1, 2, 3 dot dot dot? 0. For 1 it's 0, for 2 it's 1, and for 3 it's 2 and so on. So what is the value of twice n multiplied by n minus 1? It is, for n being 1, it is twice n and n minus 1. 2 multiplied by 0, which is 0. 4 multiplied by 1, which is 4. and 6 multiplied by 2, which is 12, and so on. What is the value of twice n into n minus 1? Plus 1. It is, so twice n minus 1 is 0, 4, 12. So plus 1 would be 1. For 4 it would be 5. And for 12 it would be 13. And so on. So it would be 1, 5, 13 dot 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 for the term twice n into n minus 1 plus 1. So if you look at these terms, first of all, these are odd numbers, and then if you look at this, let's say if I divide the first number by 4, it leaves a remainder of 1. Let's say the second number is 5. When 5 is divided by 4, it leaves a remainder of 1. For 13, the third number, let's say 13, the third number, when this is divided by 4, it also leaves a remainder of 1. So in this series, for this term, for this expression, for values of n being 1, 2, 3 dot dot dot, it will always have a remainder of 1 for all positive integer values of n. So this is how you can show that this term will always leave a remainder of 1 when it is divided by 4. Alternatively, you can also show, if I use the term twice n into n minus 1 plus 1, if you look at this term n into n minus 1, n into n minus 1, so this term will always have one even and one odd number. So the multiplication of an even and odd will always yield an even number. For example, 8 multiplied by the previous number 7 is 56, which is an even number. You can use any number to check this formula. Multiplication of even and odd is always an even number. So this will always yield an even number. So if I multiply this term by 2, or even this even number by 2, this will always be a multiple of 4. When it is divided by 4, it will have a full number, a whole number. So this term will always be a multiple of 4. When divided by 4, this will yield a whole number. This will be a multiple of 4. So what will be that this term plus 1, when divided by 4, this will always yield a remainder of 1. So this is what I covered in the last two videos on how to prove mathematical facts with algebra. So I hope you liked the contents of what was covered in the last two videos. So in the next video I'll cover another topic. So thank you for watching till the end, and hopefully I'll be able to produce better content in the future with your help. So thank you for watching.